In this video, we're going to prove the first principle of finite induction. Let S be a set of positive integers with the following properties. The integer 1 is in S, guaranteed. Whenever the integer k is in S, the next integer k plus 1 must also be in S. So, given this, then we want to show that S is the set of all positive integers. Now, just to show you what's going on and why it's reasonable for S to be the set of all positive integers, we are given that 1 is in S. Okay, 1 is in S. But whenever the integer k is in S, the next integer must also be in S. Well, this is in S, it's an integer, so the next integer must be in S. Okay, this is in S. Oh, so the next integer must be in S. This is in S, so the next integer is in S. In fact, all the integers are in S. And thus all the positive integers are in S. And that is, after all, what we want to prove or show. So here's the proof. We'll do it pretty much by contradiction. Let's suppose S does not contain all the positive integers. So let T be the set of positive integers that are not in S. And we're going to make an assumption. Assume that T is not empty. T is not empty. T is a set of positive integers. So, by the well-ordering principle, T has a smallest element. Call it A. Okay. Now, A can't be 1 because 1 is in set S. And T is everything that isn't in S. Since 1 is in S, and S is the smallest positive integer, that means that A is bigger than 1. But that implies that A minus 1 is positive. A minus 1, well, let's argue it this way. A minus 1 can't be in T since A minus 1 is less than A, and A is the smallest element in T. So, A minus 1, since it's positive and it's an integer, it must be in S. But wait a minute. If A minus 1 is in S, that implies if you add one more, whatever you get, which is A, must also be in S. But that's the contradiction. That is, if A is in T, then A is in S. That can't be. So the only assumption we made is that T is not empty. That implies T is empty, but that implies that S contains all positive integers. Because if you think about it, you think about it, S union T is the set of all positive integers. But if T is empty, that implies S union T is just S. Because you have S and you add nothing to it. Because that's what union means. Everything in S and now add in everything in T. But there's nothing in T. So you get S. That is S, which is S union T, is the set of all positive integers. And that completes the proof. If you like videos where we do proofs all the time, then you really should subscribe to my channel, as that's all we do here. If you have a theorem, that you'd like for me to prove, leave it in the comment, and if I know how to prove it, I'll definitely get right to it. Leave a comment if you like the video. Leave a comment if you hate the video. Most of all, folks, watch and learn.